Thank you, Ajit. Good morning, everyone. Indeed, it's pretty exciting times. Now, I'd like to talk to you about the unique opportunity in front of us, where we have and now we can build, the future. Um, Technology, if used right, will lead us to a better world, especially now that hopefully the pandemic is behind us, but yet we're facing certain, uncertainties from climate as well as geopolitics. So we have a lot, that we need to do to make all of this a reality. Allow me to step back, and let's all see how we got to where we are today. Um, and it's been a good, ride. Starting with the first generation analog mobile communications in the 80s, and in that era, we think about mainframe computing, stovepipe applications, and all and on to the 1990s, where we got the second generation digital mobile in 1991, uh, bringing in text services as well as personal computing and the first generation of the internet. And on to third generation data in 2000 that brought us mobile computing, especially with the launch of the iPhone in 2007. And this is where we start to see the next generation of the internet or Web 2.0, which is best described as social web, social interaction, and also bringing a lot of user generated content, a lot of video. And in 2010, 4G LTE, the true mobile broadband experience, was launched in late 2010. And that really caused the Web 2.0, the unique 4G experience I would describe, to really, happen. And at the same time, we have app economy exploding. Now, Ajit has mentioned about Volti. Volti happened in 2014, so you have a full stack of a 4G LTE enabled, phone with the network that's all IP. And then lastly, just a couple of years ago, um, and this starts the 2020 decade. We have the 5G NR launch for both mobile enhanced mobile broadband and fixed wireless access, or 5G home, in April 2019. So with that as a background, let's go on to the first slide. So the relentless wave of innovation is pretty amazing, and we've heard a lot of it, described and discussed, in yesterday's sessions. And allow me to quote Jerome Powell in the conclusion of a speech he made. He's the Federal Reserve, chairman, where he says, we live in a time of extraordinary technological change. We should be open to new ideas and innovation that will drive economic growth. And this is, particularly important, especially with what we're doing in OpenGen. And towards the end of the slide, I will focus on that as well as the vertical priority on 5G connected drones. So the left-hand side, just list, what, we've been talking about, uh, from virtualization to, 5G innovations, taking advantage of mobile edge computing, where you have low latency and, data closer to where the user is at the edge. We have network slicing that allowed us to uniquely provide the requirements of, for example, an enterprise or vertical to include full isolation where security is needed. And of course, we have the mobile IoT and industrial IoT. And lately, there's a lot of buzz with extended reality that encompasses virtual reality and augmented reality. We've heard a lot of artificial intelligence and learning and all this, allowing us to get to robots and industrial automation. And blockchain, plays an important role in making all this happen. So we've heard about Web 3.0 and the metaverse. We've heard about Industry 4.0 and digital transformation. So it's interesting time when all of these technical innovations are converging at the same time. Please go on to the next slide. We have 5G, coming out of 3GPP and getting deployed, right? So the initial focus has been the enhanced mobile broadband in the 5G phase one, typically, release 15. So 3GPP is the global standardization. They've been working all of this, mobile communication technologies, and 5G at this time really is taking us beyond, mobile and user communications to making a difference towards enterprises, industries, government, and even military, right? So Release 16 added on support for verticals, including enhancements around URLC or ultra reliability, low latency communications, as well as support for V2X. Release 17, which has just been completed, this year, June this year, in fact, uh, added support for mission critical as well as satellite access, or what 3GPP referred to as non-terrestrial, network, as well as private networks. And since a lot of we're talking now are drones, we have a feature that applies both for 4G LTE and 5G NR, support of UAS or unmanned aircraft systems, starting with remote ID to connectivity and C2, and allowing integration of 4G and 5G networks to the the UAS traffic management. And there's a lot, I think, that needs to happen to really fully realize that. Work is taking place today on Release 18. It's kind of like, labeled as 5G Advanced, introducing artificial intelligence and extended reality. And as far as drones, 3GPP will continue to work enhancing support of unmanned aerial for NR, especially in terms of mitigating interference that may cause as more and more drones fly up in the air. At the same time, 3GPP is looking at broadcast remote ID capability as well as support for detect and avoid. And then lastly, work is starting in the requirements group in 3GPP to look at metaverse along with integrated sensing and communications. And added to that, our ambient powered IoT and service robots. So as you can see here, we're starting to push the envelope, and what we're hoping to do is get this all realized, within the fifth generation. And if that happens, in a good way, then I think we are in a successful path to 6G. So next slide, please. Now, all of these technologies, both in the industry as well as in mobile communications, the challenge that we have is how can we take all that and unleash it to transform how we do our work, how we live. An example of the verticals that are actively part of 3GPP as market representation partner, you can see on the left, uh, working with the mobile ecosystem, right? And taking on the unique requirements and how they want to enlist this and transform fundamentally, how they do things. So we are at the tipping point of a major retooling. And as far as the U.S. is concerned, there is, national effort to make sure that we have, public funding, right? And realize this technology to secure our position, in leadership, making sure that we are protected as well as providing for jobs, and what could be, education driven, towards 21st century for, the U.S. Citizens. So if you go on to the next slide, now from here on, I'm going to touch more on 5G connected drones. So what we have and what we see here is the global effort and collaboration, bringing in the mobile industry by way of GSMA, as well as Global UTM Association, bringing in aviation and drones into a collaborative activity called ACJA, or Aerial Connectivity Joint Activity. Now, ACJA had a couple of work streams where it coordinates work and features that are happening in 3GPP, as well as on the aviation and drone standardization side, work that's happening in the case of the US RTCA, as well as in the case of Europe, EUROCA. And ancillary to that, would be standardization work around remote ID and UTM, again, ASTM global, but US, focus, as well as ASD STAN, right? So you can see here industry, standards, and then very important really are the regulators, the regulatory, entities or authorities that also, provide, inputs to how this is all going to work out, right? So on the mobile ecosystem side, we have the FCC, right? And on the right side for aviation, we have the FAA in the US as well as EASA in Europe. So it's important that all of this is coordinated, right? And it doesn't really matter who comes first, because all that is important here is this should lead to an interoperable services, right? As well as a safe integration in the case of drones and flying vehicles into the national airspace. And it is a very kind of like coordinated work that happens in different places. Now, taking it from the global to the next slide, please. Okay, well, I hold up to the next slide. So here, what we see is the first deliverable that came from ACJA and GSMA by way of the LTE aerial user to network interface profile, or NG128. So this is now an industry guideline. And what this describes is a common reference implementation set that the aerial UE and the network need to implement to guarantee an interoperable service. There's been discussion yesterday around C2 and how that's differentiated from, the commercial payload, the business or the mission of why we're flying the drones. So taking that, the profile recommends or mandates actually the implementation of a well-known UAS access point name, where you will have the quality of service, right, needed for critical communications, C2 as an example, as well as non-critical communication, operational state of drone, telemetric type of, sensor data, as well as on the right side, a general purpose internet APN, but also could be quality of service differentiated for the business of, flying the drone. Now, very important is what it says at the bottom. The LT aerial profile also make strong, recommendation in features that were delivered in 3GPP release 15 for LTE to mitigate interference, as well as improve the mobility of these flying UEs or flying drones. If we have to scale, we need to make sure that the network is optimized, right? And manage this potential interference, protecting, the ground users, right? So I'll touch on that once we get to kind of like, talking about the test beds. And on to the next slide, as I was saying. So Verizon, it takes pride in our participation in Open Generation 5G Consortium. and we believe in its mission of securing and taking the U.S. leadership in the 5G technologies, working with both academia and industry, taking on the first vertical, which is, as we know, 5G drones. And what we see here is, we can work together to accelerate innovation in a collaborative, vertically driven, R&D and experimentation. And you've seen the, published output, of the OpenGen so far, right? But there's a lot of work that is taking place in terms of identifying, use cases, building the architecture, and applying that in setting up, the test beds, as well as getting ready with the technology solutions in the pipeline for experimentation. So if you go on to the next slide, please. Okay, now I'll spend a bit of time on the test beds because at the end of the day, this really allows us, to do what we've embarked on. So we have two outdoor test beds and one indoor, as we've heard yesterday. So I'll start with the new air test bed, one of the designated FAA, UAS, and UAM test sites in Rome, New York. It is anchored, in Griffiths Airport. South of that, we have a public safety, test site as well. And so today we have a live private 5G network, 5 mile in radius, and it's configured with a standalone 5G network using a commercial sub-6 gigahertz spectrum, right? So we're looking to optimize and get that test bed, ready to take on, solutions to be experimented on. And designated test cases, that it would take, are listed below here, starting with hazmat as part of an emergency response, package delivery, static infrastructure inspection, and urban air mobility, which is the last use case, that we've worked on in MITRE Ingenuity OpenGen. And going to the next, Virginia Tech, Kendon Farm in Blacksburg, Virginia. So we're still in the process of setting up the test bed. It will be private 5G network set in a rural farm. Virginia Tech has a farming agriculture research facility in this location as well, and it's configured for dual connectivity using 5G millimeter wave with an LTE anchor band. Again, commercial spectrum. So it's slated to initially take package delivery and static infrastructure inspection. And what I'm hoping is we could also take that into smart agriculture and really run the innovation that is actually inherently in that facility. So the combination of these two beds will allow us to do a lot of different things. And our expectation at Verizon is, we should actually put an effort besides the pipeline of activity within the consortium, also invite others, to run experimentation, right? And really maximize the use of these test beds. It's not so easy to actually build, a standalone private network, that we use for, experimentation. So, and that's why, it's taking some time, right? But once we have it, let's maximize and let's invite others to actually take full advantage of it. Now, it was also mentioned yesterday that we have an indoor facility, an anechoic chamber, in Northeastern University at their Burlington, Massachusetts. And that is actually using a standalone 5G configuration using open source, as well as sub-6 and millimeter wave spectrum. So the target there right now is looking at indoor inspection, especially around warehousing. So if you can just go quick to the next slide. Now, the main point I'd like to impart my keynote is the importance of bringing in regulation input, so we get into a regulations driven innovation as well. So again, we have the unique opportunity to identify, areas or implications of innovation and work with government regulatory agencies to support its rapid and safe introduction, with emphasis on experimentation in an iterative trial of this innovation, again, taking regulatory needs. And that would allow us to build dialogue with the public and industry on how technological innovation are regulated. And the last slide, my conclusion, is it will not amount to anything, right, if we don't take this out of the labs and the test beds. So we share the vision of OpenGen towards a 50-mile UAS corridor when we combine the private networks and the public networks to allow for a path to commercialization. And key to this as well is, public-private partnerships, especially at the state, county and local level, where we can all work together, to make all this happen. So again, thank you for the opportunity and allow me to give you, my thoughts. And thank you, and hoping that we have another second day of excitement as we had yesterday.
So, good morning, everybody. I hope you can hear me okay, and good afternoon and good evening, depending on where you are in the world. My name's Adrian Buckley, and I'm a principal engineer at MITRE. So before I go into any more about myself, just want to thank Gerry for those great slides and overview that he gave. Really liked the opening section, specifically on where some of the standards started, where they're going, and the challenges that they've been facing. Got to say, I wasn't around for the starts, the very first 1G, but my career started soon after in the 2G area. So with that point, so let's go on to who am I, and what are we going to be doing this morning. So again, Adrian Buckley, I've got 30 years, just shy of 30 years actually, of wireless experience with operators and vendors on 3 continents. I helped deploy 2 GSM networks. One was in the UK, the other one was here in California. And nearly all of those years, I've been doing standards of some form or another. Started in ETSI, now in 3GPP, and also doing IEEE, SAE, and various other things. And over all of that time, I've also helped and have over 200 plus patents granted to my name that have helped evolve the wireless industry. Now over at MITRE, I'm fully supporting the Open Generation Consortium, and as well as doing standards work, which I'll just jump onto in a minute, I'm also overseeing one of the test beds that Gerry made mention into his latter slide, specifically the Virginia Tech test bed, where Gerry made mention that we were going to be doing millimeter wave. So going back to the other activity that I'm heavily involved in over at OpenGen is where I'm actually leading the standards effort there, identifying particular organizations that we should be involved in. And one of the most instrumental things that I helped OpenGen do was late last year, we became a marketing representation partner of 3GPP. And now I participate at PCG and plenary level. And so we're going to use that particular vehicle to take the outputs from our test beds. So there we execute experiments. We're going to get some results. And hopefully we're going to, take those results, take them back into standards and other fora, and help those particular fora, guide, where they need to go for the particular ecosystem that we're investigating at that particular time, which the first one is going to be the UAS ecosystem. So with that, let's move on to my next slide and have a look, at this particular UAS ecosystem. If you have a look here on the left, you'll see that there's many use cases where drones are actually being used today. But if you delve really into what those drones are actually doing, you'll find out, that they're only really scratching the surface of what can be done. Something like beyond visual line of sight will, accelerate these, use cases and assist the industry in getting along. And what do I mean by BV loss, and how can it assist the industry? So let's take the hazmat use case, which is one of the use cases we're going to be studying at our new test site. You can imagine today, if you have a hazmat incident, the team is going to go out to that particular incident. They're going to arrive there. They probably really don't know what has happened. Best case they might do. And they're going to have a drone. They're going to visually watch that drone, and inspect the incident. And they're going to capture some video footage, some data, and then analyze it, and see how to act upon that. Now imagine that you had BV loss capabilities. You can instantly send the drone out to the incident location, flying over people via missing trees and things like this. And once you get there, you can then start to ascertain, what's happening at that particular incident location. You can capture data, you can stream video back and everything like this. And so therefore you can ascertain what is happening in a quicker time at that particular location, and then adapt the people that you send out there and make better use of your resources. And to actually implement something like BV loss, you're going to need things to avoid other air vehicles in the air. You're going to need to be able to avoid trees and other things in the way, and you also need to be conscious of of who you're flying over, and what data you're collecting. So how do we make BV loss a success? And that's what the first three panels are going to be looking at this morning in some more detail. So let me delve into those particular panels here. Let's move on to the next slide. So the first slide here is it shows us that we've got a panel on making detect and avoid a reality. It's going to be moderated by Stefano Ficin, who's a director of standards over at Qualcomm. And here we're probably going to be touching on things like how do we avoid other planes and helicopters in the air, without having somebody there, actually visually inspecting the air and avoiding those things. How are we going to make efficient use of the airspace? And then another thing is kind of how we're going to make this all predictable. And these issues Stefano will delve into a lot more detail. And then after that, we're going to have the second panel is going to be on regulations and legal aspects. And here we have Ken Stewart, who's CEO of Newair, and basically a bit kind of like discussing, the kind of like the boundaries that could be set for the industry. And, what do I mean by the boundaries? As I mentioned in the use case that I described, you're going to be flying over people. We have to make sure, that we're going to be safe for those operations. What do we need to do to make sure that we're safe? We're also going to be collecting data. What data can we collect, and how long we can keep it for. And then maybe some of these regulations actually, you'll find out that some of these panels can kind of inform the other panels, or I should say the topic areas. So, regulations can also be helped to drive things like, detect and avoid. And then also regulations can be used to drive what our final panel is going to be talking about. And our final panel is going to be talking about standards. And here we have Barbara, and I always make a mess of her last name, so sorry, Barbara Palagregno, who is from the GSMA Association, where she's an executive director concentrating on the drone ecosystem. We're going to be looking at standards, and standards can assist in making things interoperate. They can also aid in developing the ecosystem and bringing the ecosystem faster to market. And standards can also assist things like DAA, as Stefano is going to talk about, and bring consistency to how that particular functionality works. So let's take DAA, and let's say everybody needs to know that everybody else is going to announce their position every 10 to 15 seconds, or every few milliseconds. And so with that, I would like to hand over to Stefano Ficin over at Qualcomm, who is going to lead the discussion on making detect and avoid how can we make detect and avoid a reality. So Stefano Ficin, over to you.